Hey class, this is Mr. Roberts. I'm coming to you from Stockton, California. I hope that yesterday you had a successful study team test and that you and your group did a good job. I will have those graded and back to you on Thursday. No, I'm sorry, I'll have them back to you on Friday. I will be back in the class with you on Thursday. Today we're moving on to section 10.1.3. I just want to quickly remind you what we did in the previous section, our book 10.1.2. Your group had to collect 40 data points. Each student had to basically stand 200 centimeters away from a target and toss these little chips towards the target. And you guys carefully recorded how far each of those were. I have data points here for two different students from the same group. And you, hopefully you have that data with you still. You may need it again today in class. So what I'm doing here is taking a look at the data set, and I've created some combo graphs, right? One on the top, I have a box and whisker plot, or a box plot, and on the second one, I have a histogram. This first one, they're basically set up each direction like this. So on the left-hand side here, I do have the box plot on top, and of course, this is the minimum value in that data set. And if I look at it, I can see that the minimum was 32, even though this isn't set up in order. The smallest was 32. And then the mean, this is actually quartile 1. That's the middle of the lower half of the data. This is the median, which is the middle of our data set. This is quartile 3, which is the middle of the upper half of the data, and this is the maximum. So the maximum here looks like it's very close to 100, and I believe it's actually this point right here, the 99. So there's in the previous section, we had the math notes. If you need review on how you basically find that 5-number summary, the minimum, quartile 1, median, quartile 3, and the max, please look that up. Once we have that, we're basically setting up a number line. Here it's roughly from 30 to 100, and then we draw at 32, our minimum, and then we go ahead and keep going until we get to quartile 1, which looks like it's around 42. This data, unfortunately, is not in order, so I can't see that, so I would draw that line next. Then I would draw a line at my median, which looks like it's very close to the number 60. And I draw one at around 70, maybe 77-ish. And then finally, I draw a line at my max, and I know that's 99. I can see it. So once I have those 4 values in, it's a good idea to go ahead and write down the values up above. So you should probably include the numbers that go with each of those on your box plot, and then just go ahead and fill this in. So this box in the middle represents the middle half of the data, and we can see where the middle of the middle is by that line called the median. Roughly 25% of your data falls between the minimum and the quartile 1. Actually, each one of these are 25%. So like this is 1/4 of your data points here, 1/4 of your data here, 1/4 of the data points are here, and 1/4 of the data points are there. So that's what that does. And if you look at it, you can see that if I compare it with the data set on the other side here, there's a couple things that I kind of noticed. This one, there's quite a large gap here, right? You can see that this is quite a large whisker. And you know, that means maybe perhaps lack of consistency. There's kind of a little bit more of a spread. However, this person was a much better shot. You can see that these numbers are all significantly lower. So this person was definitely closer to the target, but they did have a couple shots that were maybe not characteristic of their play in general. In fact, that one data point, this 77, is really what's creating that kind of a large visual here. I'm kind of pulling that over like that. So let's just briefly talk about the histogram below. So this histogram is set up so that it's got 5 bins, and that's what we call these. Each one of these are bins, right? It's between a couple numbers. It's a bin, and this is a bin. So these gaps here are bins. So when you're setting up a histogram, usually we start at the 32. And you can see that we're ending up, our largest is 99. So roughly what I have to do here is I have to go from 99 to the number 32. And if I divide that by 5, I would be creating I would find the width for each of the bins. So essentially what it would be doing is that I'm saying, hey, I'm starting at 32. I have to make it to 99, and I want to know how wide each of my bins has to be in order to end up with 5 bins. So I've got 92 minus 32, which I believe is 67. And I'm taking the 67 and I'm dividing it by 5. And it's not the most exciting number, right? It's 13.4. So honestly, what I would probably do is, I'd fudge this a little bit. I would probably start at 32 for my min, and then I would add like 13 to that. So if I add 13 to the 32, that gets me to the number 45 about. And then if I add 13 to that, I'm at the number 50, 58? If I add 13 to that, I would be at 60, 70, 80, 8, 9, 10, 11. So what, 62? No, 63. No, third time's the charm. I think it's 71. 71 plus 13 is 80. What, 80? 84-ish. So anyways, you get the idea, and then 84 plus 13 would be 97-ish. So it's a little short. But anyways, I've now kind of designated my 5 bins for this data set. So if I want to go through now and place this data to create my histogram, what I do is I look at each of my points. The first one there is the number 32 right here, and that 32 is in this first bin. So I would make a mark. I'm just kind of tallying them up. And actually, when I do that, I would probably just write down a tally mark right here. There's one that's in that range. The next number in that list is, I can't even see it for the life of me. It's like 96. So I would write, let's see, a 96, I would make a little mark over here. So there's a data point there. The next one's 57, which would be in, interestingly enough, in this little range. Then I got a 59, which would be, just inside of this one. Then I've got a 71, which would be, that's right on the border. I guess I'll put it in this one. Then I've got a 99, which would be in my last bin. Then I've got a 78, which is in roughly this middle bin here, or this bin. Then I've got a 62, which looks like it's in this bin. And then I've got a 36, which looks like it's in this bin. Then I got a 45, which looks like it's, geez, that's tough. Just looking at how my data went up above from the one that GeoGebra created, I'm going to throw that last one in here. So what happens now is I'm just looking at my data and I'm trying to roughly figure out where these values go in terms of the 5 bins I've created. And you can see my tally marks. Now, how I use that then is I go ahead and take those values, and you can see there's a 3 here, a 2, and then a 1. Well, I had 3 data points in this bin. That's why there's a 3 there. The next one over, there was only a single value in that bin, so that's why that's a 1. This one had 3 values in it. This one had 1 value, and then this one had 2 values. So I can finish this off by drawing these down. And this is, unfortunately, this is just kind of the mechanics of sketching out a histogram like that. Let's move on. So lesson 10.1.3, how can I compare results, comparing data? In the previous lesson, you tried to decide which team was the most consistently close to the golf hole. Comparing sets of data is an essential part of the study of statistics. Data is often not meaningful unless it's compared to other data. What does a batting average or free throw average mean if you're the only person who has one? Or what does your SAT score mean if there are no other scores with which you can compare it? So we're going to begin our discussion of how do we compare data. Question 40. Please make sure you write down 40 and you include your responses for both for A, B, C, and D. So as the managing grower at the at all organic orchards, rather, you know the farmer's market will only accept fruit that is above average size for your orchard. However, they do not define how to calculate, quote, average, unquote. Meaning, are you using the mean or using the median? Those are two different measures of central tendency or middleness. You want to sell as much fruit as possible for premium prices at the farmer's market. We're trying to get the most fruit there. So, and if we can pick mean or median, it's kind of up to us to choose. Your apple crop is represented by the histogram and box plot at right. To get the maximum amount of fruit to the market, should you use the mean or the median for the average? So remember, the median is the middle value. So if I'm taking a look at this data, I know the middle of my box plot right here, this represents the middle if I'm thinking about the median. So if I'm picking the median, that means that I could send this fruit and this fruit to market because those would be above average. But it would only be those, right? Those ones in these ranges. Now, because of this outlier, you can see it way down here, there's some particularly small fruit that's kind of skewing the data quite a bit. Or actually, it's not, I should be more precise. It's not skewing it, but it's definitely having this effect of pulling the mean further down. So I'm not exactly sure where it would be because I don't know really what these numbers are, but my guess is somewhere along in here, if I had all these values and I calculated, the mean would be there. And again, the reason why is when I add these particularly small numbers up with all the others and divide by how many data points I have, that's pulling it down quite a bit. So that outlier is really kind of pulling the mean to the left of where the median is. So if that's what I was going to pick, then I could get this fruit, this fruit, this fruit, and this fruit to market. So probably it would be advantageous for me to use the mean as my where my above average or below average fruit is mean. Is that fair? Probably. I don't know that it is. I think probably I'm picking that value to kind of suit my purposes, but I don't think that the mean really reflects the middle of the data. I think that those outliers are kind of affecting that quite a bit. So anyways, you can think about what we just said there and pause the video and just kind of look at this question A again. It says your apple crop is represented by the histogram and box plot at right. To get the maximum amount of fruit to market, should you use the mean or the median? So think about that. Make sure you write down your response for A. Let's move on to B. Pause if you need to. Your lemon crop is represented by the histogram at right. Why do you suppose the right whisker is missing? Which average should you calculate? So let's look at this one. I'm guessing the reason why that right whisker is missing is because Q3 and the maximum are probably the same number. So this data set is definitely, and you can see it in the shape, right? This data set is, I think this we would call skewed. So you can see it's kind of pulled off to one side and it's doing this thing, but then it's not, notice it's not really coming back down at all. It's just kind of staying up there, and we can see this. Well, I have a feeling that this value right here again is my median, and if I was picking this, that would allow this fruit and this fruit to be above average. But I would say again, because this data set is skewed, it's pulled off to the left like this, that probably the mean would be somewhere, and I'll switch colors, but probably the mean is, I don't know, somewhere down in here. I don't know. I don't think it's quite as dramatic as the last problem, but the mean's a little bit more over here. So probably I would get just a little bit more of my fruit. The lemons would make it to market if I was picking the mean again. So, and I think that's probably what the idea is here, right? Either we've got these outliers that are causing the mean and the median to not be the same. This outlier is pulling the mean down. And over here, the fact that it's skewed and my data is kind of pumped up is kind of causing my mean and my median to be off from each other a bit also. Let's see. So for C, it says, why might the farmer at the orchards feel like you were being deceptive and reporting the mean? Well, I have a feeling that, like we were saying, if your data set has some outliers, some values that are either particularly low or much higher than the bulk of your data, and I can see that kind of nicely in this box plot that these really are outliers. So if your data set has outliers like that, you might use the median. The median's probably a better measure of where the middle of your data is. Now, we didn't use the median, we used the mean because we're trying to sneak more fruit in. But if there's an outlier, probably the median is a better indicator of where the middle of your data is, or what a typical what a typical apple looks like. And the same thing for this. If your data is skewed, the fact that it's skewed off to the left like that's probably pulling the mean down from where the median is. So if you've got a skewed data set, or if you've got like a data set with outliers, probably you want to be looking at the median instead. And in fact, the question B, I think I just kind of answered that, so you might want to rewind it and think about that. But it says to best represent numerically the center or typical value of a large quantity of data, when would you use the mean and when would you use the median? So some things to consider there in terms of outliers and skewed data sets. Question 41, home sales in Fancyville and Smallville are shown in the tables below. Calculate the mean and median sales price in each town. Then it says compare Fancyville to Smallville. In which town does the quote typical unquote house cost less? So as I'm looking at this, the one thing that's catching my eye is this data is not in numerical order at all, but I'm noticing that in Fancyville there's definitely a couple of houses here and here, for example, that are pretty dominant outliers. So, and they're actually above, I think, where the bulk of that data is. So in that case, because we've got an outlier, probably we should be considering looking at the median, because I think those outliers are going to cause some discrepancy. They're going to kind of skew. They're going to be a little bit deceptive if we're looking at the mean. But do what the book said. I mean, you have to order the list from least to greatest, and then figure out what the median is for each set of data, and then go ahead and add them up and divide by how many there are to calculate the mean. And then when you're answering the question, just be aware of the fact that those two large numbers, these are in thousands of dollars. So thousands. So the 200. That's $2.8 million, and those are some expensive houses, because you got to tack 3 zeros onto the end of those. But just be aware that those outliers are kind of causing they would be pulling the mean, I think, up higher in Fancyville than it probably should be, because I think the median is probably the one that's more towards the center there. So go ahead and pause the video and give yourself some time to write your response to 41. This question is interesting to me because I noticed some of us were doing this on Thursday when we were plotting some of our golf data. It says Cyrus has the idea to compare cells in Fancyville to Smallville. Let's make a scatter plot with Fancyville on the x-axis and Smallville on the y-axis. Then we can draw a line of best fit and see if there's an association. Ramian responded, that's a great idea. And then the question is, what's wrong with Cyrus and Ramian's plan? What would be a better plan? So I'll just say that the thing about a scatter plot is when you're using a scatter plot, what you really want to see is, and I'm just grabbing an XY axis here. What you really want to see is each piece of data should have two numbers associated with it, right? So each house could be like, you could be looking at square footage and cost, for example, or number of rooms and cost. So each one of those has, two numbers associated with one physical item. The problem with this is that, I'm looking at, it says, what are we going to do? It says, then we can draw, let's make a scatter plot with Fancyville on the x-axis and Smallville on the y-axis. Well, I'm not even sure how I would do that, right? Because, what would this point represent? So again, I think the problem with the scatter plot idea is, again, normally a scatter plot, every single dot they would represent one house, and you're showing two attributes of the house. Like I said, it could be like the square footage, and then up here it could be the cost. And you might want to flip those around, but I don't think it's a good idea in fact, I don't think it would work at all. Now, I think what I want you to spend some time though is answering this question. What would be a better plan than creating a scatter plot? So spend some time discussing that, and then go ahead and answer that question. What do you think would be a better way to look at the differences between Smallville and Fancyville? Okay, it is definitely a short Wednesday, and probably those first questions, 40, 41, and 42, are a good stopping point for us. So if you have time left in the class, I would like for you to begin working on this homework assignment, questions 46 through 52 in Chapter 10. Remember, tomorrow, in addition to checking that homework assignment, I also need to check this one. Although I'm not exactly sure why. Maybe I don't need to check that one. Maybe I do. But anyways, both of those should be done. So if I haven't checked the 33 through 39, I need to check that. But your homework for tonight is 46 through 52, so you should start that now. Have a great afternoon, great rest of the day, and I'll see you in class tomorrow.